Hello there. What I'd like to show you today is a little bit of a game where we use some maths to play. So in this game, we are playing as this little blue character, and we want to fire at this dot over here. Let's take a look at what happens when I press this fire button. So when I press that fire button, I launch a projectile that's travelled 45 meters, and the direction that it has travelled is straight north. If I change this angle here, you can see my character is rotating, and if I increase the range and press fire, you can see it now shoots at a different angle and travels 85 meters. So we can see at the top of this that one square has a side length of 10 meters. Let's see if we can hit our red dot. So if I change my angle, that looks like it's going to hit. Maybe say that would be 60 meters, 50 meters perhaps. Let's try 55. Press fire. Our range was pretty close. Maybe increase the range a little bit and rotate it left a couple degrees. So I've rotated left 2 degrees, increase the range, fire. Perfect hit. Okay, let's see if we can do that again. This one looks pretty close, so if we just rotate a little bit past 90 degrees, set the range to maybe 30 meters, 28 meters, 27 meters. Perfect hit again. And look, we've got one which is almost straight north of us, just a few degrees off. Right, that's pretty good. But what we're really interested in doing here is using a bit of maths to see if we can get that shot perfect. So you can see that our number of hits is a little bit less than the number of shots we've taken. I'm actually going to press that restart button to get us right back to 0 hits, 0 shots, and see if we can get it right on our first try. So, if you haven't noticed already, we actually get to use Pythagoras' theorem to solve the distance from us to the target. So going to my working pad over here, I've got this nice little right triangle formed, and we can see that the target is about 10, 20, 30, 40, 50, 60, 70, 80, maybe 82 meters away, and 28 meters away horizontally. And we want to figure out side C, which is that direct distance to the target. So we're going to use our favourite Pythagorean theorem to solve this. A squared plus b squared equals c squared. 82 squared plus 28 squared is c squared. 28 times 28, we can use our calculator to solve that one for us. 784. 82 times 82, 6,724. And adding these together, we get 7,508. So this isn't the distance. It's not 7,508 meters away. That would be ridiculous. But we do know if you get this side C and times it by itself, so something C times C equals 7,508. We want to reverse this. So what number, when you times it by itself, gets to 7,508? Fortunately, we have the square root function. If we do the square root of 7,508, it gives us 86.65 roughly. So if you do 86.65 times 86.65, you get 7,508. This means this distance is 86.65 meters long. So if we go back to our game and go 87 meters, that's going to get our range pretty much perfect. We're still guessing the bearing a little bit, but our range should be on perfectly. Oh, first try, wonderful. Okay, we can also get the angle that we shoot at, and to do that, let's actually put this game on hard mode. So this little button at the top puts the game in hard mode. We'll restart this game so it's back to 0, 0 for all the points. And I just want to show you what's going to happen here. So if I'm pointing at a bearing of 0, when I press fire, it should fire straight north. Great. If I aim at a bearing of 90 degrees, that means we're firing straight east, because we've rotated clockwise 90 degrees. If I'm firing at a bearing of maybe 246 degrees, we're rotating 246 degrees clockwise from the north line of our blue point. So if we go 90 degrees, 180 degrees, 270 degrees, we'll be firing towards the left. So 246 should be firing down there. Let's see if we're right. Yeah, perfect. 246 is firing down that way. So let's restart again, because I want to get this score perfect. Let's make it an interesting target. Okay, let's see if we can hit this one here. Let's get some new working space. So we're going to start by drawing our triangle and calculating our distance. So we know it's 10, 20, 30, 40, 50, 60, 70, 80, 90 meters tall. Goodness, that's far away. And 29 meters across. So we can go a squared plus b squared equals c squared. 90 squared plus 29 squared equals c squared. 90 times 90 is 8,100. 29 squared is 841. Adding these two values together, we get 8,941 is c squared. So to get c, we just do the square root of 8,941. Going to go to our calculator again. 94.55. 94.56 meters even. So if we set our range to 95 meters, we should have our range correct. Let's see if we can do the bearing now. So to do the bearing, I really do need to know the angle that goes all the way around that way. Well, to get that angle, what I am actually going to solve is first figure out this angle, and I've labelled it theta, and we can use trigonometry to figure out the side theta. So you can see opposite theta we have our 29 meters, and adjacent to theta we have our 90 meters. So I can even say that tan of theta is opposite divided by the adjacent. So tan of theta equals 29 over 90. So to get theta by itself, we're doing the opposite of tan. We're doing arctan, or tan -1, or maybe even shift tan. And we type just this into our calculator to get this angle. And that gives me 17.9 degrees. So this little interior angle here is 17.9 degrees. That means the outside, this angle here, plus this exterior angle must add to 360. So the actual bearing that I'm firing on is going to be 360 take away that 17.9 degrees. Looks like I should be shooting at a bearing of 342.1 degrees. Let's see how close we can get this. So if I point my bearing 339, 40, 342, set the range to 95 meters. Boom! How about that? Bang on target. One hit, one shot. Reckon we can do it again? Let's see if we can make it a little bit faster this time. So again, taking a screenshot to do a nice working out, and I'm going to go quite a bit faster this time, but we can see we've got 3 meters that way, 10, 20, 30, 40, 50, 60, 61 meters that way, so 30 meters and 61. Let's go with a squared plus b squared equals c squared, 30 squared plus 61 squared equals c squared, 900 plus 3,721, I think, c squared, 4,621 equals c squared, square root we get 68 meters. Alright, now let's try get the angle. So I'll solve this angle this time. So to get theta, tan theta is opposite over adjacent. So we can go theta equals tan negative 1, 61 over 30. And we get 63.8 degrees. So again, we do want this angle all the way from the outside there. So if you spin 90, 180, 270, plus that 63.8 degrees, you get our actual bearing. So we do 270 plus 63.8, which gives us 333.8 degrees. Alright, let's try that bearing. 334 degrees is our closest, and our direction, our range, 68 meters. How about that? Pretty good. Oh look, this is a free shot, 90 degrees right. And all we have to do is count the boxes. 10, 20, 30, 40, 50, 55 meters. No maths even needed this time. Isn't that neat? Well, I hope you enjoy playing this game, and it's nice to see that we can use a little bit of maths to solve our problems in the real world.